Again, thank you for being here, Mike and Lisa, and I'll just turn it over to you.
All right, great. Lisa did mention something earlier and mentioned serverless. I'm a software developer by heart. I've been in technology probably over 20 years. I've been in Colorado since '98, and I started developing before that. So I've done a little bit of front end, back end, military infrastructure. That's my bread and butter was software development. I did everything. I've done DBA. I started with SQL Server back in 1996. Also Access a little bit. Back in 2018 was a SRE managing a Kubernetes cluster. I have to say, I haven't done a lot of Kubernetes in a good while. It's definitely rusty. Thank you, Lisa, for letting me do this because it's definitely encouraged me to get up to speed on it again. And probably over the last 10 years or so, I've been a system architect working for enterprises. But I have a picture over here on the right-hand side. This was from last week. This is Camp Roach. 250 employees went 2 hours north of New York City to this camp. We had dodgeball, we had kickball, we threw axes. I'm on the solution engineering team. We cooked barbecue. I say this because I've been here for 7 years. I haven't worked at a better company with better people, with a great product. If you know someone's looking, and this is no one asked me to say this. This is from my heart. I highly recommend you look at Cockroach Labs. Here's my LinkedIn profile. I do have a Stack Overflow profile that has about 11,000 points. I have to say I haven't put much into it lately. I've been encouraged to put some Cockroach DB stuff on it. Most of it's software development, but hopefully I'll get back onto that. I guess I am a AWS certified solution architect. That has expired, just so you know that I do have some cloud experience. And then for Cockroach Lab, I am a solution architect. I work on talking to new prospects and customers and identify where Cockroach can help them out solve pains. But just as important is to identify where the technology does not work. And we'll talk about that in a little bit. Agenda. So first thing I want to learn is, well, my background as a developer. When I think of Kubernetes, I think of SREs, I think of DevEx, I think of DevOps. There's multiple terms here, and this is really catered to you. Also, when I think of like Kubernetes, I think of microservices, not so much as databases. We think of stateless sets or stateless applications. And then we're going to dig into Cockroach DB a little bit, and then do a demo, and then do a Q&A. I do have let me see if I find it here, a Slido. There we go. A Slido. So if you can go out to Slido, type in this code, you can ask questions here. I probably won't get to these till the end. And then also we will also do a poll to just see who's here and what's important to you. And that's really my big thing. I want to understand what's important to you, and then we can probably cater some of this conversation, this presentation to what's important. So with that being said, we got one question, but I'm not going to do questions right now. I'm going to go ahead and go to the polls and make it easy. And the easy one is, I do know that this is a Utah Kubernetes meeting, but we are virtual. So it'd be kind of nice to see if anyone is here outside of Utah.
We've already failed you.
Why is that? We got Utah.
We're just Utah and Colorado.
That's all right.
Our word cloud will be very small.
Yes. Well, we have limited people, so it's okay.
Mike's in Colorado. Did he mention that?
Yeah,
yes.
Yeah. That's my name out there. Yeah. So first of all, I live in Denver, Colorado. Love it. Similar to Salt Lake City area, Utah, dry, great weather. I tell people I moved here for the snow, but I stay here for the weather, the summer, the sun, and everything. All right. Looks like we got Utah and Colorado in the house, and Lisa's in
California. I guess I should play this game too.
All right.
That thing.
Let's do this. Let's talk about what's important to you. This is when I think about this, I'm thinking of, it could be, I don't know everyone that's on this meeting, tailored to SREs and people who are managing, making sure applications stay up. I do know that there's a couple of things that are important to me as an SRE. I'm going to actually put a couple out here. I'm not going to put them all. There we go. Perfect. We'll give a couple more minutes Yeah, so reduce operational overhead. No, everyone's done that so far, and that's one of my biggest ones is about efficiency. So great to hear that. Zero downtime as SREs. It's important. Your website has to be up always. I mean, as soon as I leave this, I may go out to order a pizza, and that website better be up for me to be able to order a pizza, or I'm going to go someplace else to order a pizza. Even things that aren't critical for life. I know pizza, some would say critical for life, but I think it's important. And then let's do one more post. Thank you very much. And we got 9 responses, and let's do this one. So where does your database run? Does it run on bare metal, on-prem? When I think of bare metal, I think there's 2 types of bare metal, even though you have cloud. First one is bare metal on-prem, and then you also have where you can run on EC2 instances in AWS or GCP, compute. Kubernetes, of course, is one. This can be Kubernetes running on your own prem or Kubernetes in any of the cloud providers. Then we have OpenShift, which is Red Hat OpenShift. We do have customers running that. We do have an operator that supports it. And then is there something else out there? And actually, I'm going to. All right. Great. Look like we still have some votes coming in. So 10 people have replied. Thank you very much. 11. Great. So what I see here, a lot of database as a service. Very interesting. We'll dig a little bit into that. Kubernetes, of course, I expect that it's we're at a Kubernetes meetup, but a lot of people do not like to run databases on Kubernetes. So when you think of stateful data, it can be difficult to do, and we'll talk about that a little bit on how CockroachDB just talk about legacy databases on Kubernetes, and also how CockroachDB kind of harnesses the main tenets of Kubernetes and microservices. So thank you very much for that information. We'll go ahead and dig into this. We already did this. What's important? What database? I didn't ask. I only had 3 questions. I used the state as one of them, so I didn't get to ask where does your database run, but that's all right. Just a second ago, I just asked these questions. What's important to you? And we're going to go through each one of these on why they're important, and we'll go through them quickly. I'm not going to bore you with a lot of details of here. You probably know that, but this is what I believe is important in regards to SREs and making sure your site's up and running, making sure you have a good user experience. The first one is when I think of SREs, I want systems that are cloud native. If they're cloud native, then they run in Kubernetes nicely. I want to be able to run anywhere. Running anywhere means on-prem in any of the clouds you want. This could be AWS, GCP, DigitalOcean, even the smaller ones. Multi-cloud. When I think of multi-cloud, I'm thinking of running not just in AWS and Azure or on-prem, but a combination of all those, which would include a hybrid cloud. So should be able to run in these major providers and run across multiple regions, but also be able to run across different providers, cloud providers. This could be also on-prem or AWS or GCP or any of these we mentioned before. And then when I think of running anywhere, I think of orchestration, and the primary orchestration tools I think of is Kubernetes and OpenShift. We kind of talked about this as like reduce operational overhead, and reducing operational overhead really is reducing cost. It's allowing the SREs, developers, and others to focus on more important tasks such as getting features out, working on existing applications, working on workflow and efficiencies, automating things, providing monitoring so you can understand what's going on, alerting, hopefully that single pane of glass. And I think another part is hopefully you're in a business that's growing. And in a business growing, you're thinking about capacity planning, and you're thinking about how many nodes I need and what CPUs I need and how to run your system. So I think that's overly important, and the benefits of why SREs are so important is really reducing that operational overhead. I worked in development for 20 plus years, and I remember doing my own deployments and rolling back, and it was just a maintenance nightmare. So very good. We're all here, I think, for one thing. As a developer or SRE or even the business, it's about getting features and functionality out to the user as quickly as possible. That's it. And everything else we do supports the developer for getting that out. CI/CD is overly important, continuing integration and continuous delivery. I think a big thing on increasing developer productivity is allow users or developers use the tools they already know and familiar with. This could be languages, this could be databases, this could be third-party services. But if they can use their tools that they know, that will help get features and functionality out much more quickly. And then the big one as a developer, I used to do Windows development. I hate to say that, but really the big thing was back then, at one point it was used to, it ran on my computer, but it didn't run didn't run in development rel. And then when they moved to the staging, it didn't work in production. So really when I think of development, you want it, if it runs on my local computer in a container, it should be able to run any place else. We talk about resiliency, and we talk about always on, zero RPO, RTO. These are things we want. These are very, very hard to get. There's no question about it. And the thing that's important here is that we want to make sure we have a good user experience. If your application's down, your database is down, your website's down, it's going to cost you money. It may cost you customers. It may cost you distraction, might be a distraction where you're supposed to be working on something else, but now you have to focus on this outage. It's table stakes. Like I said, I'm going to go probably order pizza after this. Maybe not pizza, maybe Thai food. But that website better be open. DoorDash is someone we work with that uses Cockroach DB. And the big thing with that is that if I went out there and ordered food and that website was not up, I would go find a different provider. And that is with most businesses nowadays. It always has to be up. I mean, there may be some exceptions. We don't work, 8 to 5 anymore. So it's overly important. Easy to scale. When I think of like SREs, I want to be able to, I think of microservices. When I think of microservices, I think of these small containers. They could be big containers that you can just add or remove based on demand. And then also be able to distribute the load across those containers, across those services. And then performance. This is back to the customer. It's really about improving the user experience. If I'm on a website or a mobile app playing a game and I click a button, I have to wait a half a second for get a response back. That's a poor user experience. Not always, but majority of the time. We want to reduce the latency of to the customer. And then a lot of this is also putting the compute and the data near the user. If you look at running AWS or on GCP, compute's pretty easy, but data can be more difficult. And we'll talk a little bit about how to put data close to the user so they have a good experience. And then last but not least, actually becoming much more important lately is compliance and regulations. We've all heard, most of us probably have heard of GDPR, where data in Europe, personal data has to stay in Europe. States now, US states have regulations on that. We work with multiple gaming companies, gambling companies, where, for example, data bets that are done in Florida has to stay in Florida. And the neat thing about this is AWS does not have a region in Florida. So how do you solve that? And then also not being compliant definitely can impact the business completely. Can cost you money and can also in turn cost where you can do business at. So with that, we're going to talk a little bit about legacy databases and just start with this, and this will allow us to learn where these fit in nicely, where they kind of maybe don't fit in as well, and where other technologies can help out. So when I think of legacy database, my background is back from 1996, I think SQL Server 6.5 with SQL Server, but I've also worked with MySQL, Postgres, Oracle. When I think of legacy databases, I think it also includes the cloud provider databases. This is AWS RDS, GCP SQL. These are just running copies or distributions of Postgres, MySQL, even Aurora, I think, as a legacy database. And I'll go in a little bit why I believe that. When I think of pros on there's a couple of really good ones. They're well known. You put me on a SQL server, I can make it sing. You put me on MySQL, Postgres, I can just jump into it. I know SQL. Some of these dialects I don't know exceptionally well, but as a developer, I could be productive on these databases very quickly. Just because I just got to change the dialect. I know how to do a select clause. I know how to do an insert. I know how to create schemas and indexes and join. So it's just simple. Another great thing about these databases, as a relational database, they support ACID compliancy. They support transactions. You really have a true view of data consistency. At one point in time, I'll get back to that a little bit where NoSQL comes into this, but when I think of NoSQL compared to relational databases, they do have some issues with transactions and consistency, and they have some dialects of SQL, but they're not really true. But when I think of cons, many of these legacy databases are not cloud native. They started out before really you had to scale the system up. SQL Server, I remember scaling up SQL Server multiple times and going from 4 CPUs to 8 CPUs, and then going from 8 CPUs to 12 CPUs is exponentially more expensive. It just gets costlier to scale up. Many of these databases can scale out, but most of the time it's read-only replicas. So you're scaling out reads, but what happens if you get a lot of writes? You can't scale that out. There are exceptions to the rules, but it is something that they don't do natively. It's not in their DNA. And then I worked with Oracle and SQL Server, solving these monolithic databases, these servers where you solve one bottleneck problem, which could be the CPU, and then you run into another problem, which is the memory. And now you get the memory get right, and now I'm working on a disk system, and now I got to figure out how to get more throughput to the disk. And I think a lot of these databases have limitations on the size they can be, the number of terabytes, petabytes they can store. If you think of MySQL, Postgres, I work with customers a lot that come from those environments to CockroachDB, and once they get to that 2 terabyte, 4 terabyte size limit, they get worried. Don't get me wrong, Oracle has a great solution to have rack, but there are definitely just pull out your wallet, put it that way. And then some people say, I can shard data. I can go out there and create 10 servers and put parts of data in other places, partition data into different servers. Do not do that. I have a friend doing that right now. I have told him do anything but that. That puts too much burden on the developer. Understanding how to work with that, creating specific schemas so to understand where data lives. That's just terrible. It doesn't scale. It becomes an operational nightmare. I have customers I've worked with a ton on this that has come to CockroachDB because they started sharding and it just doesn't work well. So we talked a little bit about legacy databases. Now we're going to talk a little bit about microservices, containers, and I won't talk about Kubernetes per se, but I have it here anyway. When we think about microservices, we think about easy to scale. Over here, we have some APIs, we have some users. If we get more demand, what do? We add some additional servers, spin up some more new pods, and we can handle that scale. Great thing about when you think of Kubernetes, these things can launch in seconds. If one of these or two of these go down, or a server goes down where these pods are running that's running these APIs, that's okay. We have 6 more running, so it's fine, and they can be redeployed later on. And a bigger one on it, for the developer, if they build it and runs in a container, you should be able to run it in Kubernetes and in the different environments. Another great thing when I think of microservices is, I know this isn't sometimes correct, PC, but the cattle versus the pet. These aren't special servers. These aren't special API systems that we're managing. Specifically, I know with relational databases, I've done that. I've run them in Kubernetes, and there is some special stuff out there, and you do know the name of them because there's only one of them. Also running in a microservice, K8s, if you're using something like a service mesh, you can improve your data security, you can better improve your data governance, and you can improve, then your CI/CD pipeline can be in there also. But the problem with this over here on the right, we have all these users, this load coming through the load balancer. We have an API, and all these APIs is hitting this database. The problem here is that the database just doesn't scale. You could possibly scale reads, but then you still have to put logic into the API to do that. It's really hard to scale writes in this scenario. You can scale up, but it becomes a problem. But let me ask you a question. What if you could have a database that has these same characteristics? What I see, well, there we go, almost messed up. This would be a database that would be distributed similar to your APIs, where your APIs hits the load balancer, and then that load balancer round robins the traffic to the database, and in turn, and also scales. And this is really what we come into when we talk about CockroachDB. We're looking for a database that's globally distributed, that speaks SQL, that's relational, that's cloud native, runs on Kubernetes, running in any of these environments, that is focused on OLTP. Key thing here, I'll just say this out the front. If you're doing log reporting, analytics and stuff, don't use OLTP database. Go out and use Redshift, which is AWS. Go out and use Snowflake, things like that. But if you're doing really OLTP transactional data, you need data consistency, you need resiliency and availability, where if a zone goes down or a region goes down, you still can service read and write requests and that doesn't impact the user experience. Where you need to be able to, there's customers that we work with right now that have overnight become successes, and they started out with Postgres or they started out with MySQL, and they have not been able to scale those. The situation here is, why not start out with a database that you can scale with, that's made to scale? And the Cockroach DB provides that. And then the other one, I'll continue to hit on this one quite a bit. Help users be developed, help users and help developers be productive. Help them get features and functionality out as quickly as possible. I'll just go through this one quickly. Why Cockroach DB? And we're gonna have a demo in a second. But let me get through these. Really, if you need data consistency, when I think of NoSQL databases, sometimes they don't do a great job on that. They do scale sometimes well. If you need to be able to survive regions or zones or racks or nodes, those failure scenarios, you need to be able to survive. Cockroach DB is a great option. When I think of improving customer performance or the customer or the user experience, putting the data close to where the customer is located at. If you're running in 3 different regions, wouldn't it be great to put that data that the customer normally access close to them? And then when you talk about GDPR, I think that's overly important nowadays, of where making sure data only lives in certain locations. This could be a specific state or specific country. And then again, run anywhere, on-prem, hybrid, multi-cloud, K8s, just be able to run your database wherever you want to. I'll go through this really quickly. System, we talked about where Cockroach fits in well. If it's an OLAP database system, maybe that's not the best bet best fit for Cockroach DB. But as an OLTP, it could be a ledger, identity management. We have a lot of companies that manage their users and identity inside of Cockroach DB, locality aware apps, metadata applications. And then we also have a lot of customers moving from these legacy databases because they need better high availability. When we think of these legacy databases, usually they're active, passive, and asynchronous. So you write to one to the active node, it asynchronously writes to another node, and then now you're going to read that data is probably is not consistent. Also, if there's an outage, there is a RPO and an RTO right there. You will probably lose some data. Sometimes it's not important, but since it's asynchronous writing from the primary to the secondary, that's certainly an issue. And then scalability, talk about that. And then one key thing here, we have a lot of customers that have started out with a relational database, has not been able to scale, so they go to a NoSQL database. But then they run into issues where now law of logic on transactions and joins and things are now in the application layer and not in the database. And now that there's a better way of doing that with distributed databases, now we see a lot of customers that have a Mongo DB or other NoSQL database gravitating to Cockroach DB because it provides these guarantees that developers expect. When I think of Cockroach DB, this is a big one. This first one, I think, is gigantic. We have customers that are running on Postgres, MySQL, and they do a schema change. When they do a schema change, what happens? That table is not available. They have to do outages. That's an issue. Where they want to be able to create indexes. Cockroach DB provides online schema changes. That means you can change your table schema, you can add indexes, you can do other things, and the database will not go down. That data will be available for reads and writes for your developers to write against and to continue to provide a great user experience. Another one that I think is overly important is upgrading your database. Usually you have a passive and an active database in these legacy databases. The issue is now you update the passive one with a new operating system or a new version of the database. You still have to fail over to that. And that means applications need to change where they're pointing to that, or that may be changing the load balancer. But there is sometimes it could be 5 seconds, could be 5 minutes. That can be an issue. If we look to the far right, these are some of the enterprise features. Many of these are important to SREs. I think encryption at rest, being able to do encrypted backups, being able to do SSO. This is talking about SSO into the database console, which is our GUI interface. We currently have a private preview into using SSO into the database itself to run SQL. And then there's a couple other things in here that I think are overly important. When I talk to developers, these are important, maybe not to SREs. Follower reads, which can improve performance. We have historical data that you can access. I won't go into all those, but really I want to make sure this stays focused with to SREs and people running these workloads on Kubernetes. Just an example here, we do have one telecom provider that has 3 regions that are running Kubernetes. They're actually running Cockroach DB in. If this one you look at the west, the central, and the east. The west and the east is running in AWS, but their central one is on-prem. Tell me another database that you can do that with, and definitely another cloud database that does that well. I don't think that's the case. The key thing here is that important to them is high availability and also performance, or that the user experience. So users access in the west, their data will be in the west. Users access in the east, their primary data will be in the east. But there's copies of these data across all 3 regions. So if one node goes down, you're fine. The users are still be able to do reads and writes. If a region goes down, you're still fine. It may take a little longer for that user, say the east went down, it may take a little longer for that user to hit the central region, but they're still able to do reads and writes. As soon as that east comes back up, the data will get re-replicated, and they will get back to where the data is close to them. Let's talk about Cockroach DB offerings. So I divided this into 2 sections. We got the left-hand side, which is self-hosted. And when I think of self-hosted, you're downloading the binary. You are running the application. Just so that you're aware, Cockroach DB is simple. We have one binary that has everything in it, which makes it nice, and 2 ports. We have ports for communication within the clients and the nodes, and we have a port for our database console. It makes it very nice for people who are managing and operating Cockroach DB in a self-hosted environment don't have to worry about opening up 20 ports or opening up limit to the ports. It's very simple to use and fairly simple to install, even for a distributed database. We also have Cockroach Cloud, and this is database as a service. So we have 2 offerings. One is dedicated. And when I say dedicated, you go out to Cockroach Cloud and say, I want a dedicated cluster. I want 3 servers, and I want, say, 9 servers. I want 3 servers, 3 in the east, 3 in the west, and 3 in the central, or 3 in Europe. These servers are dedicated to you. Currently, this is available for AWS and GCP, and we have another offering that will probably be mentioned sometime, I think this week, but there's other additional offerings coming in the future. Neat thing about this, you can do VPC peering, so if you're in AWS, or it's not private link, I think it's also called, those things are available. The one I like to talk about, I'm excited about, is serverless. And really, when we think about Cockroach as a database as a service, Cockroach Cloud, it's really talking about taking all that work and effort that you do to manage it yourself and letting us manage it. We have some of the best SREs out there. It's amazing what they can do. I've worked with them on a regular basis. But the key thing here over on serverless, I assume many of you probably heard of AWS Lambdas or GCP functions. You just go out there and say, I need to run this script, or I need to run this Python thing. You have no idea what servers are underneath the covers. What we do with serverless, and I'll talk a little bit about this more in a second, is really the key thing I'm focusing on is elastic scaling. It scales based on your load. If there's no load, it goes down to 0. You don't get charged for the compute. You might get charged for storage, but storage is fairly inexpensive. It's also fully managed. It's self-service. we automatically scale, say that at first you have 10 users using it, you go up to 1,000 users. In the front, we'll automatically scale the compute pods so that you can handle that load. And it happens excessively fast because we have like these hot pods in the corner just waiting to take your load. And this one right here, if you're not using it for development, this is amazing. I'm a developer. I've used this, and I would use this anyway if I wasn't working for cockroaches, because I can go out there and spin up a development environment with one node, or actually there's no nodes in there, with put data in there, put a schema in there, and just start developing against it. If it doesn't go anywhere, no big deal. It just stays out there. You're not getting paid for it. You're not paying for it. Not being charged for it. It just works. But if it does work and it does get super popular, it will scale with your needs. It will scale with your demand. It will scale with your business. And then there's other tools out here. We talked about there's a REST interface. There's a CLI. I think there's a Terraform provider coming out that will be provided, that will be available. So just something about Cockroach Serverless. And one other thing about Cockroach Serverless, it's simple to get. I think Lisa mentioned this a second ago or earlier today. It's very easy to get started on. You go out there to cockroachlabs.cloud. You click on serverless, figure out the cloud provider you want, you figure out what region you want, and you hit create your free cluster. You don't have to provide a credit card. It's just free for you. So I highly recommend going out there and doing that. And actually, I know Lisa has this thing right here that if you want to take a screenshot of this QR code, it will take you directly there. And then we won't go into the use cases. I think I mentioned that earlier, but we're in every industry. I don't know if there's an industry that we don't work in. And when we talk about use cases, I don't know if there's a use case out there other than, like I mentioned, reporting and analytics and heavy aggregation. I'd say reporting and analytics and things like that. And then just so that you're aware, we work with some of the largest companies in the world. They depend on us. We depend on them. They have helped us make our product better. I've only been at Cockroach Labs for probably 7 months now, and you don't know how much feedback I get from my prospects and my customers that I work with on a daily basis saying, hey, we need this feature, or this would be great if we did this differently. And in turn, it would be they help us be better. And we definitely cater to customer use cases and what they need. With that, I've talked to about 25 minutes or so. Let's go into a demo. I'd like to pause for questions, but I'm afraid if I ask questions now, it may go get a little too deep, and I won't have time to finish up this. So let me see if we do have any questions. Usually having a.
We only have the same one.
Oh, okay. Oh, we only have two. So okay.
Oh, we have two now. Okay.
Obvious cockroach can't make a equivalent of Postgres. What would be your top request if you could choose? I actually have some good answers on this. So obviously, and so we're talking about Postgres. So Cockroach DB is, I didn't mention this earlier, I should have. Very important. Cockroach speaks Postgres. We're wire compatible with it. There are some features that aren't available. We don't have triggers. We don't have stored procedures. We don't have things like that. I'm not going to say they're not coming. Huh?
Skip locked.
Skip locked. So there are things that are we are working diligently to, I wouldn't say we support everything that Postgres would support, because there's certain ways how a distributed database works instead of a legacy database, but we are working on those things. And I would say keep your ear out, and maybe even this week we might have some information provided on some of these things that are coming out. And then are there any plans eventually having a self-hosted version? I can't comment on that. So, but two good questions.
But one thing I want to mention, Cockroach DB serverless is not beta. It's actually GA. It went GA last month sometime. So I just wanted to make sure, and also just to reiterate, it is free, up to 5 gigs of storage, 250 million request units per month. So free forever. And if you go beyond that, it's not going to cut you off. Things just get a little slow. So you just will then like put a credit card in, and you can put a cap at $10 a month and it'll warn you, but you never lose your data, you never lose anything. So it's actually really flexible. It's a really cool thing, but it is GA. Go ahead and run your production apps on it. Why not?
Yeah. Great. Yeah. And I truly I think like MongoDB, one reason they became popular is it was easy to get up and running on it. I think CockroachDB serverless, that's the primary thing, is that all you do is, I mentioned this earlier, is that you go out there and create a cluster, you get a connection string, and you put that connection string in your application and then be able to work. I've worked with one customer. What were they using? They were using MySQL with Prisma, I think Node.js, which as their ORM, they changed the connection string. They weren't using functions and things like that. They changed the connection string, and they put CockroachDB as the database, and it went out and created the schema in CockroachDB, and it also changed the load. Don't get me wrong, it's not normally that easy, but it was a very, very positive experience with them to be able to go to serverless that easily, and then get off of their legacy database. And then also taking the, and actually I'm working with prospects right now who are thinking forward. The big thing is like, you know what, we're creating this game, and if this game makes it big, they actually created a previous game and it made it big, and they had some major issues. And there's like, we're creating a new game. If it makes it big, we do not want to worry about scalability. We do not want to worry about performance. We don't want to worry about having to do upgrades or something in the middle of the night that affects half the user but doesn't affect the other half. My big thing is use the tools that are out there, and Cockroach Serverless is a great tool. I won't say do it for everything, but definitely get started on it, play with it, and do it right now. If you did that, if you did want us to run things self-hosted, which we do have customers that still want to run self-hosted, you still can do that. But as a development environment, it's great. So let's talk about the demo a little bit. So we're going to run CockroachDB on Kubernetes. And I highlighted 3-4 areas right here that we're going to focus on, that we're going to be using running CockroachDB. We're going to use stateful sets. Stateful sets are going to create pods. We're going to create some services. And then those pods are associated with some storage. I love this diagram. I saw this diagram back in 2018, 19. I thought it was the best thing I ever saw. Everything I heard about Cockroach up to this point was abstract. And I was like, well, what's the deployment? What's a endpoint? And I could not understand how all these pieces work together. And once I saw this diagram, it was like, I'm a diagram guy, and you may see that in a little bit. This just opened up how, at a high level, how Kubernetes works and how the different pieces work together. What we're going to do, part one here, we're going to have an AWS EKS K8s cluster up and running. It's already up and running. I'll show you what I did to get that up and running. It runs in one region. We're going to run in 3 zones. We're going to create 3 CockroachDB nodes or instances in each one of these zones. We're going to have 2 services running. The first one is going to be a headless service. Really, I don't have arrows to it, but really it's just for Cockroach to initiate and get DNS entries and be able to communicate with each other. And then we're going to have another service which is public, internal to the cluster, and that just allows other applications to talk to CockroachDB through that. And as with that, there's a load balancer that acts as a load balancer. And then we're going to do some failure testing. Second part, we're going to scale the system. We're going to scale up to 6 nodes. We're going to add additional service. We're going to add a load balance service in AWS. This is going to create a AWS load balancer. And this is going to allow us to connect our database console to it and a SQL prompt. This could be a monitoring tool. This could be a query tool. This could be a developer tool. This can be whatever. Just want to show that how you can connect to CockroachDB outside of the Kubernetes cluster. And then we're going to do 2 other things. We're going to do rolling updates on how rolling updates work without any downtime, and then also be able to scale without any downtime. And earlier I did mention we're going to do failure testing. This is going to be simple, but again, without any downtime. So, do I have another slide here? Yes, I do. So, just so that you're aware of what I've done to get ready for this, really the only thing I've done is gone out to AWS, create a Kubernetes cluster by setting these, by running this command. A couple of key things here. You'll see I have 6 nodes. The reason I have 6 nodes is that originally we'll start with 3 instances of CockroachDB running. and then we'll scale up to 6. I don't want to wait for those nodes to get created on Amazon. So I went ahead and just started 6 nodes. This is running in US East 2. And then we also have it running in 3 different zones. So we have the Kubernetes cluster. These 6 servers will be across these three zones. So with that, I think that's all I have. Let's get busy. So I have some notes I'm going to follow because I sure can't remember all this off the top of my head, and I don't want to make too many mistakes. So I'm going to go through this. So as I mentioned earlier, we already have an EKS cluster up and running, and I'll go ahead and run this, and hopefully all my notes are in line with this. So we can see the clusters up and running. We can see all the subnets associated with it, and we can see the VPC associated with it. And the version is 1.22 of Kubernetes that we're running, so that's great. We'll also, since I did this EKS create cluster, it automatically created me a Kubernetes context. So this is awesome. I don't have to go in there and create a context myself. It already did it for me. Just FYI, I did have to download this CLI. I'll provide some links to this in a little bit. And then let's look at nodes. So now we're going to get away from the EKS control and start working with kubectl and see how many nodes we have. We currently have 9 nodes. And let's go ahead and look at one of these nodes just to see what it looks like. And we'll do, oops. No, oops, something's not working. Pile. Compare and prompt. We'll just do it. Describe node IP-192-168-2. So a couple of things I want to point out here is that we can see that we have 4 CPUs, and we have 16 gigs of memory. One thing I recommend if you're running Kubernetes or you're running CockroachDB in a production environment, we would normally recommend at least a minimum of 8 CPUs and 16 gigs of memory. But this is a demo, so I went ahead and just put it to 4 and 16. Another thing is that we can see what the number of CPUs is available. It's a little less than 4 CPUs. And we can see also the memory is a little less than 16 gigs. So what I'm going to do here is I'm going to, so this is important because if I just went out and downloaded the YAML file, the configuration files to run CockroachDB, actually, let me do one thing real fast, LS. I'm going to do RM, pretty sorry. Hopefully I didn't mess up anything, just so we can start from scratch.
Can you guys do that, or do you need Mike to make his terminal bigger?
Oh, yeah.
Bigger's probably better.
We can do that.
Cool. I can barely see it, so I can only
All
imagine.
right. No.
Room.
How about now? Is that better?
It's good.
Perfect. All right. So first thing we're going to do is to get CockroachDB running, we are going to download a YAML file. The YAML file is a CockroachDB stateful set YAML file. I'm just going to hit enter and download it. And if we want to look at this, we can go down CockroachDB stateful set. That we're creating 2 services in here. We're also creating a pod disruption budget. This is being deprecated by Kubernetes. Really, what this tells us to do that we can only have maximum of one CockroachDB node not available, so it won't take down additional ones. A couple of things also look in here that we're going to change, which is important, is the CPU and memory limits. So I'm going to go ahead and look at my notes here. Make sure I'm in the right place. And we can push this up. Usually what I like to do, at least on Kubernetes and what I've seen other people do, is do one less CPU and then do one less gigabyte worth of memory. So earlier, I think it was at 15. So we'll put this at 14. And then we'll put this down to 3. And usually these should be always the same. There's no reason to have these different. And just so that you're aware, when I think about databases, they're stateful applications. They definitely, if you have multiple pods running on that's the same instance, there can be a situation where you have noisy neighbors. I can't recommend this more than anything else, is if you have a database, especially CockroachDB, it should run on its own server. with Kubernetes managing it. So let's do that. And then we're going to scroll down one other location here. I'm going to show you, well, if I can see it, this right here, just so you know. So this is going to start the Kubernetes node up. It's not going to instantiate it, but it's going to get started. So we're doing a couple of things here. We're doing insecure. This is easy. This makes it easy for a demo, but we do provide TLS where the communication between the nodes or the cockroach nodes are communicating over TLS, and the client is also. We're also telling it to join these other cockroach databases. And then last but not least, I'm going to add one additional thing in here, and this will come to light why I'm doing this, but let me go ahead and do it now. Let me do I.
Like movie night out there in Utah, or the power went out or something. They're all sitting in the dark.
It's to see the screen. We turn
Oh,
it.
perfect.
You see it's a projector, so.
It looks amazing from our view. It just went black.
So one thing I'm doing is change the locality here. When CockroachDB starts up, each one of these nodes start up, it's going to say, where do I live at? We're going to use this for monitoring and understand latencies and be able to get some better visualization. So I'm saying these nodes I'm creating are being created in US East 2. And so let's go ahead and escape that. Whoops, wrong window. Escape, WQ. Hopefully I did that right. And let's go ahead and do this. Get pods. We're going to do -W. There's probably no pods out here, which is what we expect. But what we're going to do now is actually going to run that safostat YAML file, and this should hopefully I didn't make the configurations incorrect on and that, and should start up the pods. As we can see, these pods are up and running. That didn't take long at all. As I mentioned, so and exos, we get 1, 2, and now that should all be running. So everything looks good there. Just FYI, these are ready to start running. But one thing we need to do before the database is operational, we need to do some type of init. And we'll do that in a second. That's when we go out there and say, hey, database, everyone's up and running. You can start initializing. So I'll go ahead and kill that off. Control C. And then I'm going to bring up a couple other things here just so that you can see what's happening. We're going to look at persistent volumes here. We have 6 nodes out there, and those are all connected to, we only have 3 pods at this point in time, as I mentioned previously, but these are connected to rewrite once persistent volumes. These are GP2 storage classes within AWS. And then the key thing here is if our pods that are connected to these die, we're not deleting the data. We will eventually just restart the node in that AZ where this data lives and just reattach it, which we'll see in a little bit. And then let's look at logs. So let me go back for a second. Sorry, I did that way too fast. So all I'm doing is saying, give me the logs off one of these servers. And if we look at this and run it, really all it's doing is saying, I'm waiting to be initialized. I'm waiting for this command to initialize me. And we'll do that in just 1 second. So what we're going to do here, let me go ahead and do this. Get pods. W, and we're going to come down here and download another configuration file, and this is going to be called cluster init. All this is for is to tell the cluster to start up, and we can look at that real quickly. So if you look at this, there's nothing exciting here at all. We're going out there starting in cockroach 22.1. Pull the image and then run cockroach and then run the init command. And it's telling it to do insecure and where the host is located. So nothing overly complex there. Come on. And then let's run that. And now we can see that the knit has happened. The different cockroach DB nodes are communicating with each other. And now the 3 nodes are up. Let me hit Control K here, hit Control K here. We'll just do.
Question.
All right. And we have our pods. And if we look at the logs on this, we'll just look at one just to see what it looks like. This is not overly important right now, but we can see that there's communication going back and forth between the different nodes of Cockroach DB. Let's look at services real fast, because I think we talked about the thing that we created. We have a Cockroach DB service, which is headless. This is where the different nodes, Cockroach DB nodes, are communicating with each other. And then we also have the Cockroach DB public. This is allowing other pods within inside the cluster to talk to Cockroach DB. Actually, I may pull something up here for a second for you.
Did someone say they had a question?
Yeah.
Oh.
Sorry, I was curious why there has to be what the point of waiting to do the init is.
Yeah.
Right? If it dynamically scales, you'd think you just make one unit anytime and you add new ones and it scales up. It seems not a problem, just seems out of place.
No, it's a great question. So one thing, how Cockroach provides high availability, I also say performance, but high availability is by replicating data through 3 nodes. And then to provide high consistency, you need to be able to get quorum out of those 2 nodes. So technically, you can run Cockroach DB on 1 server. But if you're doing a replication factor of 3, you need to be able to at least write to 2 nodes. So if 2 nodes are not up, then Cockroach DB won't be high available. Does that make sense?
Yep. Okay. I got you.
Okay. Perfect. I mean, and actually, we have people who go out to dedicated and spin up 1 node, and they use that just for development. And they have 1 node, and they don't need high availability because they're not developing for high availability. But once they go to production, and you can do this too. I mean, not always recommend it, but if you're doing a development environment, you can go out there and spin up 1 node. But just expect that if that node goes down, you do 2 nodes and one of those nodes goes down, you're not going to be able to survive. But it's just for testing schemas and things like that. It's a good feature. But there's also other features of having data across multiple nodes. We also store historical data too. So you can go look, but I think Oracle has this. I think some other databases is like, I want to look at data since 5 minutes ago. And maybe stale consistent data is okay. But thanks, Carson. That's a great question. And thanks, Lisa, for bringing that up.
Sure. You also have a question on the on your poll on your app thing. I'm sorry, I forget what.
Oh, what kind of
metrics thing you're using?
Yeah.
Yeah. What kind of metrics can you get from a database cluster?
Yeah. Actually, you can get a lot. So in just a second, I'm going to show you our DB console. But we also integrate with Datadog, and we also integrate with Prometheus. So you can add those sidecars to that. And then if you're running in like Cockroach Cloud, right now we're shipping logs to the different cloud providers, tools like CloudWatch for AWS, and metrics will be coming at some point in time in the future.
Awesome.
Carson, did I answer your question?
I was thinking about what I would miss if I didn't have it. And I think it had something, but.
Okay, and we'll go to some of the, in a second, I'll show you some of the metrics. And what tools do you currently use for like monitoring like metrics and alerting?
I'm happy if it's got a Prometheus exporter, I'm set. So that's, if that's the way it is, then we're all good. So
okay, yep. Perfect. All righty. Glad that worked out. So what I want to do now is I want to connect to a Cockroach database. I want to get to a SQL prompt. So hopefully this works. So what I'm doing, why is that? Yeah. I'm going to say kubectl, start up a new instance Cockroach DB. I make it interactive, run this image. Actually, it's 21.1.7, which is different than what we're running, but that's okay. Remove it, and then really the key one right here is the SQL command, start SQL for me. So we're going to do that. Hopefully this works. Yay. Demo gods are with me. And we're going to do a couple of things, just make it really simple. We're going to treat this like any other day. We're going to show that We can do like any other Postgres database. We speak Postgres dialect. We can show databases. Keep me honest because I misspell quite a bit. So, whoops, we don't want to do this. Databases, bases. So we have 3 databases out there. We have the Postgres database because if you're working with Postgres, you expect a Postgres database out there, and the schemas and the different integration points. Right now, what I'm going to do, I'm going to create a table called customers. One key thing when you create a cockroach database, a table, lots of times if you work with legacy databases that you're working with automatic generating IDs that are incremental, one thing we recommend is using some type of random value. The reason for this, it spreads the data across the different nodes more efficient, and so forth. So, but what we're going to do here is I'm going to create a table. I'm just showing that this kind of just works like a Postgres database for the most part. We insert some data.
So you support auto increment. That still works. Just not recommended for.
Yes. Yes, it's supported. So if you had a schema and you just want to bring it over and see if it works, like we work with customers on migrating. First thing is take your schema and move it over and get it to work. Period. And then once that works, then start importing data.
Okay.
Just FYI, we do have, if you're on AWS, AWS has a great tool for migration to Postgres, Cockroach DB, and it's AWS DMS, AWS Data Migration Services. Just want to throw that out there. If that's something that you're interested in doing, going to Cockroach and migrating off another service. And this could be migrating from Postgres, MySQL, SQL Server, Oracle, and there's some other ones too. So just want to throw that out there. I have customers currently using that, and it definitely helps them improve their migration process. So what I just did here, just did a select clause from it, just showing that I was able to create a table, insert some data, and to select some data out of it. Nothing overly interesting, but still want to show that it's currently working. So I'm going to throw this diagram up 1 second. Not that one. So now what we want to do is, so we showed how to, actually I'm going to bring this down, and I'm going to share this with you in a little bit. These are my notes, actually. We just did this. We just had this pod. We had a container, which was just Cockroach DB SQL client connecting here, and it did some inserts. It did create a table to one of these nodes. I don't know which one. It could be any one of them. All of these, actually, one thing to mention here, I didn't mention in the previous part of the presentation, is that when you think of legacy databases, you're thinking of a primary and multiple secondary nodes, and only one node can get the writes. In Cockroach DB, all the nodes are writable. All of them are active. All of them are readable. That scales your writes and also scales your reads. So just wanted to throw that out there. And then what we're going to do right here, we want to do this right here. We want to actually access the Cockroach DB from outside of Kubernetes. So I'm going to come up here and grab this command. I probably should have shown this at the very beginning and add this. So I'm going to come down here and do, actually, we do this. We duplicate this. Duplicate. Come down here. Whoops, daisy. So I can look at my command at the same time I'm typing it. And let me go back to my command prompt. So I'm down here. I'm in the SQL command prompt. I'm going to come back up here to my directory. I'm going to create a new YAML file, a configuration file called vim crdb-lb YAML. And then I'm going to take this, and it's probably easier to see here. And really, while I'm doing it, it's creating a service of load balancer. And this will go out and create my AWS load balancer, and also create a service, a Kubernetes service load balancer that will distribute the load. So copy, and let's hit WQ. And so if we go back out here and hit services again, get services, all looks good. And now let's do CRDB. So I don't have to type it out. QHub, no, we don't want to delete it. Let's create it. And then get services. This has already created the service. It will take a little while for AWS to actually create that load balancer. It only takes a few moments. But let's go ahead and we got our services. What I want me to do this. So what we want to do now is make sure our connection's there. We want to connect to Cockroach DB from outside of the cluster. So this is the external IP address. I don't have anything special. I don't have a VPC. I don't have a VPN or anything, or that I'm connecting to. I'm connecting to it from my computer over the internet. So 1 second. Let me throw this in here. Just pow. And then we throw this in here. So all I did is say Cockroach SQL. This is a Cockroach binary I'm running on my computer. It's the same one that is running in Kubernetes in the Kubernetes cluster. But all I'm telling is to do Cockroach. Give me a SQL prompt. Here's the host ID and make it insecure. There we go. Now I should be able to do what was that? Show tables. Select, if I can spell, star from customers. So able to access the cluster from outside. This is kind of cool, but I got something even cooler. This is like the glitz and lamb and all that. So really, we have a tool called DB Console, and just a little bit ago, Carson, I think you asked about what metrics are available. And you can use Prometheus, which is completely fine. Some people enjoy using this. It's just simple, easy, get up and running. So I'm going to come out here, throw this in. I'm taking that load balancer DNS entry and just putting 8080 on the end of it. Then that's how we get to our get to the different types of metrics. So we can come in here and look at different metrics. We can look at hardware overview, how many SQL statements are coming in, how many SQL connections there are, replicas. We won't go into replicas. We can even look at hardware, what CPU is doing, what memory is doing, disk megabytes. So this is a simple place. This is a great tool to give to developers. It really helps them see certain things. We can see databases, SQL activity, which can tell you what what transactions are running, what sessions are running. This is the neat one. This is latency. So we have 3 nodes out here, and I can tell you what the latency between those three nodes are. All of them, well, some of them are 72 under millisecond, some of them are a little more than a millisecond. So, and then if we were running multiple regions, we could click on region, and that would tell us all the regions that it's running in and how far apart they are. I'm going to do one thing here. I think this is kind of a cool feature. Here's all our nodes, and we can tell how long they've been up. We won't worry about replicas. That just means how many copies of data. Since we write the data to 3 times, to each one of the nodes, we should have the same number of replicas in each one. And a replica or a range of data is just a subset of the table. And then we can see what our memory usage is, what we're on, and the status of the thing. Up here, we can also see the number of nodes. Okay. So one thing I want to do here, I want to go to this view right here, which I think is cool. This is an enterprise feature, but I still think it's really cool. It shows you, let me go back. It shows you a map of where your nodes are and where they're located at. Earlier, when we created those original nodes, those Cockroach nodes, we mentioned for it to be in US East 2. So I'm going to do a couple of things here to improve that. Since that's an enterprise feature, I need to set 2 settings. I need to tell the cluster what my organization is, and I have a super secret key that will provide some of these enterprise features. This is a key that's only available for 30 days. So if you did use it, just be aware if you started using enterprise features and it started working, it would expire after 30 days. So we did that. Now, if I go back over to this, we're going to see, let me get rid of that bad boy. Not that one, and hit refresh here. I say refresh, that did not work. I knew the demo gods were going to kick in at some point. Let me go back over here. Did I do something wrong? Oh, I did. No. Let's run each one of those individually. There we go. And there we go. All right, now let's see if that will work. Not that one. Not that one. For whatever reason, I can't ever find that one. Okay, so we don't have a map up yet, but we do have a node in here, and we can, or we do have a region. We do have 3 nodes in here. We can click into here and see what the CPU is, what the queries per second is, how much storage there is, and a lot of information. I'm going to go, and we can dig into individually these nodes too by a graphical interface. But something else I want to do, I actually want to see where they actually live, like in a map. So I'm going to come back over here to here and actually tell CockroachDB inside a SQL statement where these nodes live. So I'm going to come back right here. And what this is doing is saying insert into the system locations table. The region is US East 2, and here's the longitude and latitude for that region. And earlier, when we started up these nodes, we told them what region they were in, but they didn't have location of where they're located at longitude and latitude. So syntax ignored. Why did that happen? Let's try that one more time. That's where this worked earlier. Okay, there we go. And then if we come back over here, refresh this, now we can see that we have one cluster. We have a cluster that contains one region that has 3 nodes in it. If we had 3 regions, it will show all 3 regions. It could be all 3 regions within the US, or it could be across multiple continents. So, and we're not going to add a load. Let's not going to run them. So now let's do one other thing. Now let's start killing some nodes off. I think that's always the fun part, and see what happens. And this should be fairly easy. So we're going to come up here and kill this off and exit out of this and do get pods -W. And I'm going to do this. I'm going to bring this in a little bit. And there's certain things we're going to look at here. We're going to look at this liveliness node here, and we're going to see these under replicator ranges being changed. And then we're also going to see this changing also. So I'm going to kill off a pod. Let me go down here and hit exit. So exit. Okay. And really what I want to show you here is that once I kill off this pod, this one right here, it's going to die. But Kubernetes is going to recreate it, and it's going to come back fairly fast. And the reason it's coming back fairly fast is that this pod, when this pod gets regenerated, it's going to get regenerated in the same AZ of where that data was located at. And let's go ahead and run it and see what happens. And we can see it's terminating. We can see that now it's pending. The container is being created. Over here, at some point, we can see that we have a suspected node that's down. And at some point, we probably maybe get some unreplicated ranges, which is fine. The only thing we don't want is unavailable ranges. When we talk about unavailable ranges, that means if we do a query, say if we lost 2 pods at the same time, that would be an issue because we wouldn't be able to have quorum, and in turn wouldn't be able to do a consistent read. So we see the under replicated ranges. Eventually, this will go back to 3 nodes. It reattached back to that data, and everything's working as expected. This is a cool feature. I think that's like I've worked with some legacy databases in Kubernetes, and it's definitely been difficult to do that sometimes. So let's do this right now. If we came out here, we can see that Kubernetes, we're running on 22.1.6. Let's do it.
Is there a question in the room?
Yes.
I thought I heard somebody trying to interrupt.
No, that was a very small child mumbling.
Oh.
Oh, you've got small children there. We can't see them. Oh my gosh.
Yes.
That's so...
She's going out now. Derek always brings his daughter.
No, it's never too early to start learning cockroach. Oh my gosh. I wish we were there. We have so many toys. I love bringing toys to kids. Like I've got all these Kubernetes fidget spinners that the CNCF gave me to give out at meetups. We're going to show up with all the fun swag. But you know the Kubernetes fidget spinner, right? Like super fun. And I love giving these out at meetups. And I have boxes full of them. So but small children do tend to wing them across the room, and they're very heavy and they break things. But let me ask, is this making sense? Because it's hard, we can't really see you, and so I'm not sure if like eyes have glazed over, if you turn the channel and you're all watching the Fast and Furious, or like, just let us know. Is any of this like resonating? Is there some? Do you have questions? Do you want us to focus on one area other than another?
No, I think you've got a pretty experienced group here. So, yeah, the questions, when you get the questions, they're typically going to be deep probing questions about specifics. I'm sure I'm confident everybody's tracking everything so far.
Okay.
We'll save the more combative ones till after the recording.
Yeah, don't worry, we'll get feisty, but we'll wait till the recording stops.
No, awesome. It's good to hear your voice. It's like I said, we can't. It's so
Yeah.
hard virtually when we can't see you, and like everybody could be taking a nap. We have no idea.
I can turn the lights on once we have one done the demo. So,
Got a dog shaking around here. So thanks, Lisa, for asking that. I have one last thing to do, and this is one of the key things that we see. I actually have two things. One is a rolling upgrade, and then scaling the cluster. So we can do this fairly quickly. So what we're going to do is we're going to edit that STS cockroach DB, and then we're going to come down here and we're going to change the version of cockroach DB. And let me find that quickly. There it is. Do I? And then change this to .7. And escape. WQ. Whoops, that's a lot of letters. I didn't mean to type. And then we're going to see a couple of things. We're going to start seeing a rolling update right here. We're going to see the nodes never go down below, go below 2. And the key thing is we're never going to have unavailable ranges. Down here, we're going to see the different, the nodes going from 22.1.6 to 21.17, into each one individually, separate from each other. And then in guess one will do it, then the other one will do it, and another one. And we'll also see the status of that node changing. So let's do that. And we see this one down here draining. We can see one dead node. It's essentially some, actually, you're also getting a warning that there's actually nodes running different versions of the cluster. So one node is already updated to 22.1.7. The neat thing about this is just one binary that has to get downloaded. It's super quick, and we're doing a rolling upgrade as we speak. So we have two nodes that are up to the newest version, and then this third one will start being worked on, and then we'll be up to the newest version also. And at this time, actually, I should be doing this. I didn't do it. I can connect to the cluster. I can do select statements. I can do inserts. The cluster is 100% available. The user is not being impacted. Writes and reads are as expected by the developer, and the customer should continue to have a good experience. So right there, I just showed you how to do a rolling upgrade. This can be difficult with some other databases. And then let's do one last thing here. We're going to change the database one more time, and we're going to scale it. And let me control. Let me do another one of these. CD, Utah. And then we're going to go back to STS. As I mentioned earlier, I originally created 6 EC2 instances. We only ran cockroach DB on 3 of those. I created 3 additional ones so I can scale easily without taking the time for those instances to spin up. So we're going to go back down to this YAML file and find where the number 3 is. Guess I probably could look at it much easier. Instances. Hang on 1 second. It should be at the very top.
yeah.
Replicas. That's not the one I'm looking for. Let me just scroll up. I know it's at the top. There it is. And let's change this to 6. And enter. Oops, don't want to do that. And escape and WQ. And now what we're going to do is start seeing nodes popping up. Right now we have 3 nodes. We can see that starting up 0 or 3, 4, and 5. Right now, the cluster will still be up and running. We should have some type of workload running against this. Sorry about that. So Sorry, from customers. So one thing interesting here is that this previous, whenever the load balancer, whenever we killed off those other nodes and brought one up, that connection was lost. So what happened was we got an error right there, and really the application would have logic, just retry logic saying, hey, you know what? If I can connect, just retry again quickly. So, and now let's see. So what we can see here is 0, 1 running. Why is it not where it's going? It should not have to do a init. And this is where the gods aren't liking me. Give it just a few minutes here. So for the most part, while this is working and coming up, this is really the end of my presentation. We talked about really what DevOps, SREs are looking for, what's important to them, what microservices provide, really discussion on legacy databases and some issues with that, why newer databases such as a distributed database like CockroachDB, what it provides you as in high availability, scalability, also be able to put data close to the user where they can be improve performance or meet GDPR regulations and compliance needs. I went through a lot of stuff. Is there anything that stuck with you, or I need to clarify, or things I can answer for you?
I saw you were just editing the deployment. I know there's an operator as well. What's the benefit of using an operator, or what else does it provide for?
Yeah, so two things. We actually have a couple of areas. We have the config, we have the operator, and the helm. If you go out to our documentation and look at that, we're kind of deprecating the helm. We're not using that anymore. We do have an operator. The issue with the operator is that you can get up and running really quickly with it. With the current version, but it's not multi-region compatible. We are currently, so as you know, I mentioned CockroachDB Cloud, Cockroach Cloud. We actually have an operator running that. We also have an operator running the dedicated and the serverless. We're creating a new operator called the Unify operator that will eventually be provided to the public. So right now, if you want to do, I would say start with the config file, with the YAML file, and use that. And you can do that in a single region. And then if you want to go to multi-region, you can easily. And I don't know why this is not starting up. I'm not going to try to debug it right now. I should just start it up. Of course, it happens on the very last part. But
I have a question about the scaling. I've been kind of waiting for this because you brought up your first three, and we wait till all three are up, and you initialize it saying, okay, we're going to have a quorum of 3.
Yeah.
And I wonder how that handles. You keep a quorum of 3s, you go up and down.
Yeah.
You know, 6 is kind of a weird number. If you were doing etcd, you would never do 6 nodes, right? You do 3, 5, and 7.
So you make a good point. So usually, I don't know if I have a diagram for this. So let's see if I can talk about this. So you mentioned there's 2 things here we're talking about. Let me see. Not there. Don't know if I have. I don't. I'll just put this right here for the time being. So 2 things you're talking about is quorum. Quorum is based on the number of rights you want. So that will always be an odd number. You're totally correct. 3, 5, 7, and then that increases your highly availability. So if you have 3 nodes or 3 copies of this data, not 3 nodes, 3 copy of this data, you can lose 1 copy of the data and you're still able to produce. If you do a replication factor of 5, you want 5 copies of that data. If you do an insert, you want that live in 5 different locations. Then you can lose 2 copies and you still have quorum and you still do read and write access. So when you come back to this thing of adding nodes, it does have some type of, so adding nodes, we're adding nodes in regards to the AZs. So we really want an even number of nodes in each one of the AZs. So if we have 2 nodes in, at first when we started out, we had, let me see if I have this. If we did a write right here on this one, a write would go here. It would go into CockroachDB. One of these nodes we call a leader. It's not really a leader, but it's responsible for that write. And then it will replicate that data synchronous to 2 other nodes. And that works great. And that's where the replication factor comes in. If we did 6 here, we still have a replication factor of 3. The neat thing about this is another write comes in, it writes to this one here, it'll write to this one, and write to this one. It'll write to different AZs. The neat thing about this is when we lose a node, we still have 2 nodes that still contain that data. So we still can do read and write operations. The neat thing about this also is if we lose this AZ here, and since we're writing those 3 copies of data to 3 different AZs, then this AZ goes down. We still can do read and write, reads and writes, service reads and write requests. Did that answer your question? I kind of went sideways on that, I think.
Yeah. So what that tells me is there's something going on within once you get 3 nodes, then you've got 3, it sounds like it's almost like 3 leader nodes in there, and you scale up to 6, you still got 3 leaders, right? Like some internal leader elections happening, and
you're making about. Oh, go ahead.
That's fine. I don't need to go deep. I kind of get it.
So the key thing here is we normally recommend minimum three nodes, but we have clusters of 50 nodes or bigger than that. And with that, we still only have a replication factor of 3 in those scenarios. You could do replication factor of 5, but in this scenario, also if you only have 3 AZs going on, then usually I think a replication factor of 3 is correct, because if you had a replication factor of 5, then 2 of those copies have to go into one of these AZs. And in that turn, you could still lose. So one of these, actually, say you had a replication factor of 5, 2 copies will go here, 2 copies go here, and 1 will go here. If we lost a AZ, we still have quorum because there will still be 3 copies of the data.
Yep.
All right. Thank you. That's sometimes hard to explain without diagrams. I don't know if that's going to come back up. I apologize. I don't see it. I'm not going to try to debug it right now because that just becomes hell. But one thing I do have here, I do have this presentation here. I'm going to share this, and let me see if I got my other copy of it here. So you can go through all my steps. So right here, there's a bunch of stuff right here. We have the community forums. If you're interested in CockroachDB, this will take you to, actually, I'll just go ahead and do this. You can ask questions, but also takes you to our docs, take you to our blogs, take you to our GitHub repository. A key thing here I highly recommend if you're interested in learning more about CockroachDB is going out to Cockroach University. This is how I learned about Cockroach, the basics, and actually dug into some features. And if you wanted to do serverless, you click on this link or take this URL. And I don't know if there's something special underneath it or not, but you can use this URL to go out and spin up a serverless cluster.
It's very special. Please use that URL. Now we want to have dedicated URLs for dedicated meetup groups, and that will give me ammo to be able to come in person and bring, swag. I will bring the small child a little Suse lizard or some kind of cute little thing that I come up, right? Because you have to have a little gecko, right? Little plushie toy or the Docker whale. I have them all here. We don't have a cockroach plushie yet. That's the biggest omission since I've started, and yeah, we're working on it.
I like the other ones. I'm not sure having a cockroach is a little toy, but maybe.
What? Cockroach is cute, right? It's like,
oh, okay, that's not bad. That's not
super cute. I mean, we'll make sure we're cute. I mean, this doesn't look like a whale, but it's adorable. So we'll make sure.
Remember Wally?
Yeah, that's true. That's true.
You can make a cockroach.
Well,
so
I want to show one last thing here. One last thing I want to throw out here before we definitely can take more questions. If you go out to this URL, HackerMD /dev, which is like my handle on the internet, CockroachDB -AWS EKS. This is everything I followed to do all this. And then, of course, there's a bug down here at the very end that I got to figure out. But also it does string prompts, so you should be seeing what I was showing you. And then also it has some teardown information on it also. Also, this actually has a lot of reference material at the very top. So this is my references to get all this up and running. This is actually very simple, but we have some stuff on here using multiple clusters on CockroachDB, enabling the node map, scaling the cluster, performance tuning for the cluster. But this was like this is like really what I follow. I went through our documentation, but I don't like documentation per se because it doesn't really show you what you should see. So I went out there, and this probably will become a blog at some point. So what I created. With that, Paul, I'll turn it back over to you. And you were saying something. Sorry about that.
Well, I just want to say this has been real, right? This is a real demo, real stuff. And we appreciate the actual nitty gritty because that's what this group likes. So any other questions before? And Lisa, did you want to say something?
No, I just, Mike, if you put the Kube Crash slide up just for your recording, I don't know how many folks visit your recordings after the fact, but those that weren't here in the beginning, if you want to keep learning about Kubernetes, and this is just all across the community, like I mentioned, our keynote speaker, one of them is going to be one of the Argo maintainers. We've got Kartik coming in speaking about his use case at DoorDash, which is going to be super interesting. Cheryl Hung is doing a keynote. She's at Apple now, but she was running the ecosystem end user ecosystem at the CNCF for years. So it's going to be really, there you go, thank you. So kubecrash.io if you want to look at the full agenda, and you can see what time different things are. And we're just trying to always bring, especially if you're not coming to KubeCon, we're trying to always bring the education to you, those of us like Paul and me who just love bringing content to the people where you are. So all of this virtual stuff has taught us how to do this over the last couple of years. So we're going to keep it going, and we've got this conference, and like I said, Argo maintainers and the Buoyant Linkerd folks are going to be a big part of it, and Pulumi and Fairwinds has got 2 projects in the CNCF ecosystem, the incubation, that they're going to talk about. So there's a lot of really cool, if your thing is like new up and coming projects, like my thing, I just love finding like the new hot project like Argo. And then featuring that as much as I can. So a lot of new technology you'll learn about, so it can keep the Kubernetes ecosystem.
Oh, we just lost her.
I think she meant alive. So we'll see that. Well.
So Paul, I hope this was beneficial. I know you want to
Very
learn
much
about Kubernetes or how CockroachDB. I think that really when we think about Kubernetes, we think about scale, highly availability, and things like that. So hopefully this answers a lot of those questions and how to get started quickly with it if you wanted to.
Well, very much so. We appreciate you, Mike. Any last questions, or are we okay?
Not for the recording.
Okay. Yeah, I know. Anyways, thank you, Mike.
All right. I'll hang out for a little bit and see if there's
And
any
Lisa
questions.
as well. So thank you so much.
My pleasure.